I'm Buff Lopez. I'm an analyst with Cleantech Group in materials and chemicals. Among other things, I'm researching innovation across the battery landscape. I've also done some research along the mining industry, and right now I'm diving into bioplastics. So pretty excited about that. DLE stands for Direct Lithium Extraction. So essentially, lithium itself is predicted to be in shortage, exaggerated by growth in the EV sector and really batteries in general as we look for to move to cleaner, low-carbon economies. But lithium itself, the global mineral ore quality for all minerals, not just lithium, is rapidly declining. But we need lithium to power a low-carbon economy, really because lithium-ion batteries aren't going anywhere. How do we do that? Enter direct lithium extraction. So there's a lot of lithium in brines across the globe, whether it's geothermal brines or salar brines or continental brines. In the Americas, there's a lot of petro brines from abandoned oil and gas wells that could potentially unlock lithium. Yeah, so DLE itself, there's some criticism over its potential to deliver lithium at scale, but those critiques don't necessarily take into account the already demonstrated technologies at scale, like those demonstrated by Livent, recently renamed Arcadium Lithium. We've also seen some commercial demonstration from China, from a company called Sunresin that has a popular DLE technology that is used by quite a number of innovators. But I think the concerns for DLE itself is the fact that the equipment that is used for DLE rapidly degrades over time, and that leads to increased operational expenses. So I think there's just some concern from critics of DLE itself over that. But also those challenges, I think, should be viewed as exciting opportunities for innovation to overcome those barriers. So DLE itself is largely an infrastructure development investment. So for those larger miners, the senior miners with more capital to invest in DLE projects, they can definitely get involved that way. But for smaller and maybe more medium VCs who are interested in investing in DLE but don't necessarily have the funds to fund a project or get a project off the ground, they can definitely invest in technologies or adjacent technologies that complement DLE. For smaller VCs that don't necessarily have the funds to finance a DLE project, they can definitely get involved with other innovators that have complementary technologies. One, for example, is Mangrove Lithium. So they work downstream with DLE developers to refine the lithium product and make battery-grade lithium hydroxide. And this is important because really the only place in the globe to get battery-grade lithium hydroxide for EVs is in China. And that battery supply chain is very constrained. So being able to do that, number one, on-site and domestically could have huge impacts. There's a really cool company out of Australia called Electrolith, and they are spun out of Monash University's a research hub there, and they are combining DLE with refining. So they're doing essentially what Mangrove Lithium is doing in collaboration with a DLE developer, but they themselves are a DLE developer, doing that refining step all in one. And like I said before, that could have huge impacts. And then a company that is doing DLE and the refining could be really significant. And I expect forward-looking, we'll probably start to see a lot of DLE developers themselves trying to implement or develop this technology in-house. 2024 is around the time that a lot of DLE developers that we spoke to for our research have sort of earmarked for commercial deployment of their technologies. So I think this is 2024, 2025 is going to be a pretty exciting space. We'll actually get to see whether these technologies are successful